Something just flipped with Comet 3I/ATLAS, and NASA is dead quiet about it. New orbital calculations from independent experts show this object is not moving the way it was supposed to, and that's where things start getting uncomfortable. The trajectory shifted, not dramatically, not chaotically, but enough that some scientists are now whispering a question nobody wants attached to their name. Is this object tweaking its own path? In the next 10 minutes, I'm breaking down the raw data, the math behind it, and why December 19th just turned into a pressure point for modern astronomy. December 19th is the closest approach, and we're dropping immediate coverage the moment new data hits. If you miss that day, you miss the moment everything changes. Now let's get into what's actually happening. When 3I/ATLAS first entered our solar system, astronomers ran the standard playbook. Speed, direction, solar gravity, mass estimates, all fed into orbital models that usually don't miss. This isn't guesswork. This is clean, brutal math. Based on that math, the object was classified as hyperbolic. Translation? One flyby, swing around the sun, and straight back out into deep space. No return trip, no drama. Except now. That math isn't lining up anymore. Data collected on December 5th shows a consistent deviation from the predicted curve. It's subtle, but it's persistent. And that's the red flag. Not noise, not error bars. A steady drift that shouldn't be there. And when something stops obeying the curve, scientists get nervous. Think of it like throwing a ball. Gravity pulls it down in a smooth arc, and you can call the landing spot every time. But if that ball suddenly nudges sideways mid-air, without hitting anything, without randomness, just a clean adjustment, that's a problem. That's exactly what 3I/ATLAS is doing. Dr. Marco Micheli from the European Space Agency confirmed it outright, saying we're seeing non-gravitational acceleration. Yes, comets can do that, but here's the twist. The size, timing, and consistency of this acceleration don't match the usual dirty snowball excuses, and that's why this just got serious. Translation time. Yes, comets can shift direction naturally. Gas vents crack open, pressure escapes, and the object gets a little push. That part is normal. But 3I/ATLAS isn't moving like a messy, chaotic space rock. The push is steady, controlled, smooth, not jittery, not random, not sloppy. And that's exactly why scientists are uneasy. Now pause for a second. Before anyone jumps to wild conclusions, let's be crystal clear. This is not about the object hitting Earth. That's not what the data says, and nobody credible is claiming that. But what is happening might actually be more fascinating than a direct impact ever could be. So let's break down what crossing Earth's orbit really means, because the wording matters. 3I/ATLAS itself is not on a collision course. What is happening is that the object is shedding material. A lot of it. We're talking heavy debris, pebbles, gravel-sized chunks, not just dust. And those particles aren't leaving the solar system. They're sticking around. Here's why that's important. When the sun heats a comet, it releases gas and dust. Fine dust gets pushed away by sunlight and disappears fast. Weeks, maybe months. But heavier material doesn't behave like that. Pebbles and small rocks are too dense to get blown out. Instead, they slow down, spread out, and eventually settle into stable orbits around the sun. Now the real question hits. Are those particles crossing Earth's orbital path? The answer is yes. Some already are. Dr. Paul Chodas from NASA's Center for Near-Earth Object Studies ran the numbers and confirmed that debris from 3I/ATLAS will begin intersecting Earth's orbit in late 2026. Not the object itself, the debris trail it's laying down behind it. And here's where things stop feeling normal. Typical comets shed debris in a messy spray, scattered in every direction. But 3I/ATLAS isn't doing that. It's releasing material in concentrated bursts through directional jets. And those jets are aimed. One major release happened right after perihelion, the moment it passed closest to the Sun. The timing lines up way too clean. Heat activates the object, material gets released, and the debris settles into long-term solar orbit. If someone were designing a probe to quietly drop material into our solar system, this is exactly how it would look. And it gets even stranger, because when scientists analyzed how this object is moving next, they found something that flat out doesn't add up. So here's where things really tighten up. We already know 3I/ATLAS is adjusting its path, but the real question is how it's doing it. Normally, comets shift direction because of outgassing. Gas escapes, creates thrust, and gives the comet a little shove. Think of it like a natural rocket engine. That part is standard science. But here's what's throwing people off. When outgassing happens naturally, it's sloppy. The comet spins, tumbles, and wobbles. Vents open and close at random spots, firing unevenly. The thrust is chaotic, unpredictable, and messy. That's what scientists expect to see. 3I/ATLAS is not doing that. Its acceleration is smooth, steady, and consistent over time. No wobble, no wild spin, just clean motion. Dr. David Faria from NASA's Jet Propulsion Laboratory straight up said the object is showing predictable non-gravitational forces that suggest a stable venting pattern. That sentence alone made a lot of people pause. Let's break that down in plain language. It means this thing isn't tumbling. It's oriented. The vents aren't popping off randomly. They're positioned in a way that produces steady thrust over time. Now yes, that could be natural. Maybe the object has a weird shape or rotation that just happens to line everything up perfectly. Possible? Sure. But here's the part that makes scientists uneasy. Remember the anti-tail? That thin spike pointing straight toward the Sun? It's still there, and it's acting like a stabilizer. Think about a rocket in space. To fly straight, you need balance. One thruster pushes forward, others keep you from spinning out. The anti-tail pointing sunward creates resistance, while the main outgassing jets push from behind. That combo results in controlled, stable acceleration, forward thrust plus built-in balance, clean, efficient, almost engineered. Could random venting plus a lucky shape pull this off? Technically, yes. But when you stack everything together, the steady acceleration, the directional debris bursts, the strange color shifts, the unusual chemistry, it starts feeling less like coincidence and more like intention. Now let's talk about December 19th, because this is when all eyes lock in. That's the day 3I/ATLAS reaches its closest point to Earth, about 1.88 astronomical units, roughly 175 million miles away. Far? Sure, but close enough for every major telescope on the planet to get a clean look. So what are scientists hunting for? Three main things. First, the nucleus itself. Right now, nobody can see the actual object. It's wrapped in a thick cloud of gas and dust, like it's hiding in plain sight. Estimates put it between 3 and 5 kilometers wide, but the shape is still a mystery. On December 19th, that changes. The viewing angle shifts. The sun lights it from the side instead of straight on. That lighting could finally reveal the structure underneath, and depending on what shows up, this conversation might take a very different turn. As the gas cloud thins out, the real moment of truth finally arrives. For the first time, we may actually see the solid object hiding underneath. And this matters more than people realize. Is it rough and jagged like a normal comet? Twisted, uneven, broken up like a dirty snowball? Or is it smooth, cylindrical, symmetrical? Because if it's smooth, that's a serious problem. Natural comets are ugly by design. They're rubble piles, clumps of ice and rock barely holding together. No clean edges, no balance, no symmetry. But if 3I/ATLAS shows a defined shape, smooth surfaces, or any kind of geometric structure that points away from randomness and towards something else entirely. Second issue, rotation rate. Right now, nobody knows how fast this thing is spinning, and that detail changes everything. Rotation controls how outgassing works. If the object is spinning fast, a steady thrust could make sense. But if it's spinning slowly, then a smooth, consistent acceleration becomes almost impossible to explain naturally. December 19th is when we finally get answers. Scientists will track brightness changes as the object rotates. If it's irregular, the light will pulse, bright, then dim, over and over. If it's smooth, the brightness stays steady. No flicker, no variation, and that result would raise eyebrows fast. Third, and this is the big one, trajectory adjustment. If 3I/ATLAS is going to tweak its path again, closest approach is the moment it would happen. Why? Because that's when Earth's gravity has the strongest influence. If the object vents gas or adjusts thrust, the data will catch it. A spike in acceleration, a shift in trajectory, no hiding it. That would be the smoking gun. So what are the explanations on the table? Let's keep it clean and realistic. Scenario 1. It's a normal comet. This is NASA's official stance. Yes, it's strange. Yes, the chemistry is unusual. Yes, the behavior is weird. But comets are messy, unpredictable, and we've barely studied interstellar ones. Maybe the steady venting, the anti-tail, the debris pattern, all of it is just a rare natural combo. Possible? Sure. But it requires stacking coincidence on top of coincidence, and that's where skepticism creeps in. Scenario 2. Panspermia. The life spreader theory. The idea that life's building blocks don't stay put. They travel. Comets and asteroids act like delivery trucks, carrying amino acids and organic molecules from one system to another. 3I/ATLAS has methanol, hydrogen cyanide, and other compounds known to kickstart life. It's shedding heavy material that will linger in our solar system for thousands of years. Some of that debris could eventually intersect Earth, Mars, or even Europa. Is that deliberate? Not necessarily. It could be a natural cosmic process playing out over insane timescales. But when you combine the chemistry, the controlled release, and the timing, it stops feeling random and starts feeling intentional. And that's why December 19th isn't just another date on the calendar. It's a pressure test for everything we think we know. Comets have always carried organic molecules. That part isn't new. Maybe interstellar comets are just nature's delivery system, spreading the ingredients for life across the galaxy without intention or awareness. That's scenario 2, and it's comfortable, familiar, safe. But then there's scenario 3, the one nobody wants to say out loud, even though the evidence keeps circling back to it. The steady signal, the controlled acceleration, the directional debris release, the anti-tail, acting like a stabilizer, the precise timing of every outburst, and chemistry that just happens to line up with life-building compounds. So let's flip the question. If you wanted to send a probe to another star system, how would you do it? You'd wrap it in ice to shield it from radiation during a million-year journey. You'd use the destination star for a gravity assist, dive close, gain speed, tweak the course. You'd drop payloads, seeds, samples, markers. You'd place them into stable orbits where they could be studied later. You'd use directional jets to maintain orientation. And if you wanted to observe quietly, without panic or attention, you'd disguise it as something natural. You'd make it look like a comet. Here's the uncomfortable part. 3I/ATLAS is doing everything a probe would do. Does that mean it is a probe? No. But it does mean we can't rule it out anymore, and that alone changes the conversation. So where does that leave us? December 19th. That's the moment of truth. Telescopes are ready. The observation window is locked. We're about to see this object more clearly than ever before. If it's natural, we'll know. Shape, rotation, behavior. No guessing. And if it makes another course correction, if the trajectory shifts in a way that random outgassing can't explain, then we're not debating theories anymore. We're reacting to data. Now here's what you need to do right now. First, subscribe to the StellarDrift channel and turn on all notifications. We're posting live updates as December 19th unfolds, and you don't want to catch this late. Second, drop a comment. What's your theory? Natural comet, life spreader, or something we don't even have a name for yet? I want to hear what you think. Third, share this video. Most people have no idea this is even happening, and if this turns out to be as big as it looks, history will remember who was paying attention. December 19th is 8 days away. The countdown is on, and we're finding out together. Thanks for watching, and I'll see you in the next one.